Let's go ahead. We can start
Uh,
with the presentation one on. I'll keep interrupting. Just don't mind me.
yeah, sure. So I can share my screen. Just give me a second. Is my screen visible to you guys?
Yep, yep.
Yeah, sure.
For the folks who are just joining, just bit of the agenda before Varun takes over the entire stage. We are the topic that we'll be discussing is majorly his journey from transformation from like AWS Glue, ETL type things to Apache Iceberg. We'll be majorly talking about that entire pipeline, um, why he chose Iceberg, how it happened, a little bit into trenches, some nuggets of information, some nuggets of wisdom from trenches, and yeah, like the traditional story of moving from traditional architecture to the new age open data
Yes.
ecosystem. So over to you again, Varun.
Yeah, sure. Thanks, Ron. So, like before starting, I just wanna thank you guys, thank you everyone for joining us today again. And as we are here to explore our journey from AWS Glue ETL jobs to our more efficient and scalable solutions using Apache Iceberg. But before we dive into our specific cases, let's quickly review some fundamental concepts we have OLTP. OLTP is basically the online transactional processing, referring to the system that our teams, mostly our backend teams and our uh, product teams are using day to day operations on the businesses. On the other side of this OLTP, we have our OLAP systems, which are mostly used for complex queries for analysis purposes. And then there is a bridge between this OLTP to our OLAP is ETL processes, which are called as like extract, transformation, loads. So that's like a day-to-day life of a normal software data engineer or a data scientist person here, and all these three things keeps our product running. So when we come to explore more about the ETLs, so we have some some traditional ETL processes which mostly people follows. First one is full database extractions, and then we have incremental databases extractions, and then we have change data captures. So all these things are used for keep up to date our OLAP systems or OLAP data, which we used for analysis. And if we talked about what are the as these are the traditional ETL processes that they are being used by every firm for their analysis purposes and all those things, but they comes with some uh, challenges, some set of challenges. Sometimes it's scalability issues with large data sets. Some complex transformations are there, and some difficulty in handling schema changes. And as we are as in this event, we are talking webinar, we are talking about NoSQLs like MongoDB and DynamoDB. They are they don't have any schemas, so it's a very difficult for following these traditional ETL processes. uh, and when we are working with the big data technologies like Spark, Hadoop, Pythons. So apart from that, there are some other challenges with these big data is they have a limited support for real time and near real time data processing, because when we are talking about the near real time and real time data processing, the data should be following the same funnel, same pipeline. But when we don't have any schema, then it's going to then it gives a uh, then it's provide then it's make a difficult to handle those things. So if I talk this all from this ETL and traditional processes. When we comes to our journey, what is our architecture before Iceberg and all those things. So I'm gonna just to quick go through this. So as our OLTP, our product database is a DynamoDB. So it consists we are and it provides us a streaming application which is called as DynamoDB Streams, which captures the item level changes or updates happening in our DynamoDB tables. So from those dynamic streams, we are capturing those changes and transforming, performing some standardization, some schema updates, and all those things using a Lambda script. And then we are storing those changes into Parquet files. As this capturing of data is in near real time. So we have a lot of Parquet files, small Parquet files getting stored in S3 bucket. So before, what we are doing is and we have AWS Glue ETL jobs, which runs our PySpark jobs. And on the other side, if you can see, there is another S3 bucket with Parquet files, which consists of the full database extraction, which we have taken out at the which we have taken initially to start to set up our ETL jobs. So, though the issue that we are facing here, like before going to the issues, then the final S3 bucket is getting used as a source of our Athena engine, which is being used by our data science business analysis teams for analysis and queries and report generations and all. If we talk about what are the major issues that we are facing in this architecture, was the rising cost associated with the increasing data processing, because the day by day, as our business is growing, was growing and is growing, so like the data is increasing. So every due to that data increase, the associate cost with the glue jobs and glue jobs and the lambdas are getting, like, mostly are the glue jobs, so it increases our costs. So that's one of the concern we have. Other than, we have the like same similarly, these longer jobs run times impacting our ability to deliver time insights. So as the data increases, the job starting taking times, and then our reports that we are sharing to our, in our teams and to our partners, so it start making a issue or challenges for us to keep our business on the way for analysis purpose as well. Okay, then when, like, after having this much of the issues, we have we gone to find some reliable thing more than that AWS Glue. Then we find out our uh, then I find out like this Apache Iceberg. So Apache Iceberg, if I talk about, is an open table format for huge analytics data sets, and mostly on like data lakes, like such as our S3 and Azure data lake systems. So if we talk about the Iceberg, why we choose Iceberg is because of its feature. So when we comes to its features, are like time traveling. Time traveling is basically, we can go through and check around, like what are the updates and changes happen to our data, so that these things help us to uh, uh, look around and check for like what is the issues, like handling with the issues and all those things. Apart from that, Iceberg provides the compliance over big data like S3 data. Like we can easily we can perform CRUD operations over due to the Iceberg supports, like creating, reading, and updating and deleting data in the bulk, even so in the bulk. And apart from that, we have the schema and partition evolution that we have uh, used in our new approaches. Schema evolutions allows seamless changes, this schema evolutions and partition evolutions allow us to easily update our schemas without the need of any data migrations and table recreations. On the other side of the partition evolutions, so uh, there is no, like, when we are using the Spark, we have to rewrite the whole data just to provide it's a partition. So update anything, or uh, introducing a new schema or any partitionings. So every times we are working with like whole data instead of the just the latest data we want to work on. And apart from that, the Iceberg has the much more support than Spark. Like Spark is mostly work with PySpark, or you can go for the Scalas. When we coming to the Iceberg, it can easily, like the ETL jobs can be easily run into Python or directly by using the Athena engine. So that's the major feature we used Iceberg for. And if I go for the like our new architecture, we have this. So if you can look here, we have just introduced a new layer here, which consists of the Lambda, Athena, and the AWS Glue catalogs, which we used for creating, updating, and reading our new ETLs, new tables, and managing our data in new ways.
Mm.
And
Varun, sorry to
yes,
interrupt. Like, can we zoom in a little bit? It's like little difficult. Especially like the photo is like little.
just give me a second.
No
I
worries. You
think
can just walk us through it. It's okay.
so. If I talk about the architecture is the same, like similar. Our production database is DynamoDB. Then data the item level changes and again captured by DynamoDB streams, and then being handled by lambdas to capture those changes into small Parquet files. But this time, instead of reading those data using Spark jobs. Here we are scanning that data again by Athena, and the final data is also being scanned by Athena just to perform upsert queries, which provide using a iceberg table formats. And so there is no need of rewriting the whole data again and again as we are doing the same as we are doing in the Spark jobs, AWS Glue jobs. So this provides a much more functionality over our latest data and reduces our timings cost. Uh, we are working with just the latest data, like the one last 1 day data, last 2 hours data, last 1 minute data, and that's all for this architecture. Like uh, after like these lambda is basic, like if I talk about it just a little bit briefly. So what happens here, lambda basically runs some Athena run some queries on Athena engine, and that Athena will handle those reads from the staging bucket to a finalized target bucket, and rewrite those data, and then writes that latest data into the final bucket again. And it's the iceberg that handles the metadata to which files they now we have to point for the latest data, and which point needs to be which points are to be like which files are to be handled now, like any schema changes are there. So all those things metadata are being handled by iceberg. And the benefits, or if I talk about the benefits and impact that we got after using our after we used iceberg in our OLAP system. So first one was reduces our processing time. Before, like if I talk about like the processing time when we were using AWS Glue was 15 to 30 minutes of timing, but we have reduced that timing to around 1 to 2 minutes. So it's a good good thing we achieved here. And then we have improved query performance, like using our as I already mentioned here, like the partition evolution. So we even in our older tables we have introduced new partitions. On that basis we reduces scanning and time in, and the basically the performance of queries we have improved here. And then we have like data governance and lineage tracking. That this this thing we have achieved using like the time traveling things, time traveler feature of iceberg. So using this, we got like how the user's data is getting updated over the journey of a user. And if and the other thing is like greater flexibility in handling schema changes. That's assuming, as we know, like DynamoDB doesn't have any schema here. So most of the time during the time testing and like testing by the backend team, some schemas are updated or some new columns are introduced there. So it's what difficult in the glue. to handle those things. Like we have to rewrite, like again rewrite our Spark jobs and then deploy them and then running the data. But here we will got here we have introduced some more flexibility using alert systems and introduce just introduce a normal CRUD operations like alter table, just smaller things like those. And other one was like a significant cost savings. Like we achieved around 95% of cost saving here over the AWS Glue jobs. And so that's all from like Rohan. And apart from the like
Awesome.
future, yes.
There are too many questions. I was like, too many questions that we have, especially on like choices of Iceberg, what was exactly happening before in Glue Jobs. I can take one by one, like a lot of folks asked about it. But before we do that, first of all, once again, thanks. Thanks for sharing the journey.
Thank you so
It's kind of inspiring, like seeing that entire glue type of architecture now
much.
moving to the iceberg, and like from there itself, like taking a little bit of jump to actually understand, like when you chose iceberg,
Mhm.
which what all other different things that you kind of thought about or tried to experiment with.
So like
Uh, yeah,
sure.
go ahead, go
So
ahead.
when we're looking for this as I'm a data engineer, we know like we are mostly working with the big data technologies like Spark, Hadoop, and all those things. But I really want to try something new. So then I got some blogs from over on Netflix. Like they have introduced something like Iceberg and all those things. Then I got into like looking around for Iceberg. Then I got some other similar things, similar uh, technologies like Apache Hoodie as well as there. But
Hmm.
I
Did you
selected
try
Iceberg.
out hoodie?
Yeah, I tried out the hoodie, but the thing is here with the Apache versus the hoodie, if you talk about like Apache Iceberg has a lot of support engines. Like even the Athena, you can like even the Athena engine can be a better option. Like similarly for our cases, you have just to write a normal queries. But if you go for the Apache hoodies, so you have to just try to have to again you have to write the for jobs in Spark, like we are
Hmm.
getting out from a
So better ecosystem support was one of the big reasons
getting out from
using iceberg.
something. Yes, yes.
Hmm. Makes sense, makes
So
sense. And we
even
touched upon like the problem was like the schema evolution, like Trait is asking about that also in questions. How
yeah,
is this schema evolution actually made better in Iceberg? Would love to understand like that upsearch operation that you're talking about. Like,
yeah,
uh,
sure.
was it like merge on read, copy on write? How were you exactly doing it?
Sure. So, like as you also know, like as I mentioned, like our database is a DynamoDB. So let's assume like for the starting of recently we are introducing a new feature in the Dynamo using our created our new tables. So at that time, the schema is not defined that time. So for the start, we use the something with the integers and sometimes with the floats. Like it's fine for the like when we are setting for the ETL, but suddenly we go for something like JSON and all those things. So it's difficult to handle all those things in the Spark. Like we have to again rewrite that jobs. Like it's a lot of efforts to do that. But when we are coming into Iceberg, it's normally like working with the SQL database. We just have to alter the data, alter the new
Hmm.
columns. It's been very easy for these things.
Hmm. So although it's like a manual, still a manual type of work of
Yeah, still,
managing those things,
yeah,
but
still
it's
it's
more in a SQL, easy SQL rather than a complex Spark jobs.
yeah, it's one thing is there like it's like when we are working with the data engineers and data scientists, so everyone knows about the SQL. So it's not now it's that much difficult to handle our OLAP systems now. Even a data science teams or any other team can easily handle those things.
Hmm. Hmm. And like, did you actually compare any other catalogs while you were choosing the catalog that you chose?
No,
Like maybe
like,
the Delta format or Unity catalog or
Uh,
maybe any other
not
thing.
like I haven't gone into like trying the catalogs because like mostly our platform tech stack is based on AWS. But yeah, I'm planning to do that. So like as we work on the as we have started our journey on doing going through going going through open source technologies, so it will be a better option.
Hmm. Hmm.
Yeah.
And what exactly used to happen in those Spark jobs? Like Manikanda was asking about like earlier architectures, the Spark jobs that you used to write. What all different steps you actually used to happen over there?
So like in that we have to like the main concern of the from Spark AWS Glue to Iceberg is to uh, first one was our cost. Like we are like increasing cost we have. Then we have a lot of efforts to have like sometimes Spark jobs are getting filled just because of the like data is increased like out of memory, and a lot of problems are there into Spark jobs. But when we come to when if I talk about the Iceberg, it's currently handled by the Athena, which is just instead of a compute based system, it's a scan based system.
Hmm.
So we are just getting charged for the data scanning.
So that
So
was like from there, like I'll kind of like take a segue to one of the Akshay's question, but one of the questions which Akshay asked, which was like you mentioned cost saving as one of the big wins for this migration. What was the parameters where exactly the cost was saved, and do
so
you actually do the replication in Iceberg, and how exactly does it work?
So in the Iceberg, like as I told you, we have already like when if I talked about the like when we are using the old architecture, we still have that same data into our S3 bucket sitting in the S3 bucket. But uh, like when we are when we create when we created when we are creating a shifting our data from Iceberg, it's just creating a normal just writing a normal SQL query, like to create something, create this table using this star from the other table that is present in Athena. And now there's just the format is different Iceberg. So there that setup or the initial full data extraction is very easy that much, like the efforts are very less. And then setuping our ETLs is first we want to work with our insert and upsert queries like on our business requirements. So and after that just running those queries using Athena. And apart from that, there are some more issues we faced, like challenges we faced when working with the Iceberg. Something like as I mentioned, like data is being like Iceberg is not writing the data; it's just appending the data into a S3 bucket. So there is a lot of file getting created when we are working with Iceberg. So for that, if we work on I introduces I use the Athena for this for the support that it provides for optimization of Iceberg as well. So there are simpler queries like compactions, like reducing all the small files, rewriting the small files into bigger files, and deleting old files is just running a vacuum and the table name. So these things I have done. And if we talk about the cost, if I just give you a rough estimate. So our job was running for 10 minutes, like when for a one I'm telling you for this one thing. So then our job is running for a 10 minute, and it's using 10 DPU. Like maybe people heard of AWS Glue charges on the basis of the time and the DPU we use. And so it's been converted into hours instead of the minute. So it's been cost, and then and it's cost it's based on it charge basis on the $0.44 to $0.24. So we are getting charged for $0.24, and which is costing around $0.4 per sync. And if you're talking about in a day, we are syncing around 12 times a day. Like it's not it's a real time, we are working with the batch sync ups. So that costs us like 4.8 a day, and then we talk about the per month, it's like $144. Like it's a
So
just
just
for
the performance of Iceberg was like one of the big reasons. Like
yeah.
instead of running that entire processing for let's say 10, 15, 20 minutes, you were able to run that in 1 or 2 minutes.
Yes.
Uh, that was one of the big reasons that
Yeah.
you were able to save a lot of this cost.
Yes. So
Hmm.
like in that time, it's according to me, like the time we are consuming here is because we are reading that same amount of data again and again and again, and it's been
Hmm,
increasing because the final data is getting increased day by day. On the other
hmm.
side, when we work with the iceberg, it's just the scanning of the data. So if I talk about, like, roughly we are generating around, mm, 1 GB of data for a table, like 1 GB of data. It's 1 GB is very big if you're talking about the, like, texting and all those things. So it's just costing us around 0.00 something. And, like, if I talk you about to for a monthly cost that we are, getting now for a table, which was like $144, and now it is just $0.35 a month.
Oh, amazing, amazing, amazing. Another one of the questions which Akshay asked was like, when you mentioned like you're running Iceberg Data Lake on AWS, which type of governance have you been using? What type governance is there? And secondly, when consumer does query from Athena, will all the operations support all the operations like DDL or DML will be supported? The
Yeah.
updates or the changes, will
Yes.
all the operations be supported?
Yeah, Ron, all the DDL, DML, like, creates update, and all the CRUD operations are currently can be happen from the Athena. So for the governance, currently I'm looking for some more, like, governance is another phase of iceberg. So currently I'm looking for ways. It will be great, like people can ping me over then, like if they have already worked on the iceberg, or we can together find a way. Like currently going to work with the data lake formation that is provided by, like, AWS Glue. Maybe there is a way we can use that.
I'm actually curious to understand, like, within the Athena, do you have you actually kind of explored that governance RBAC side of ecosystem, or like how does that work today? Like, or if you give access to Athena, like everybody will be able to access.
Yeah, so for that, currently we have provided the access to just for the, like, leads and all those things. And apart from that, most of our reports have been generated using our Lambda and EC2 scripts. So from there, we are controlling our uh, controlling our controls, or like this,
Hmm.
permissions, authentication, all of those things. Like in future,
Makes
we
sense.
still want to work on this something, like it's a one of the another major uh, challenges to uh, face in the future.
Hmm.
Yeah.
Makes sense. Makes sense. Kind of like a follow-up to this question, which Akshay just asked was like Athena don't support all the operations by default for Iceberg table. It's controlled by access governance. So I'm assuming that was the answer to my question, Akshay, but just trying to like reiterate, I think that is what just Varun also just shared.
Yeah, so for now, like, according to our business requirements and according to my findings, that I think the support that Athena provides for iceberg is much more than that we required when we are working with iceberg ETLs. So, like, just
Hmm.
compactions, like cleaning up the data and rewriting the data, apart from CRUD operations.
Hmm.
Even though, like, if you are looking for something more internally, want, like, if you want to more uh, work with your iceberg, or want to like handle something more, so I think we should go for some other catalogs or other open source engines like the Trino and Presto. Yeah.
Makes sense. Makes sense. Actually, I'm kind of curious. Like, we'll get back to the audience questions, of course, but just like from our conversation, I
Yeah.
got a kind of like a curious question. Like, we are talking about a very standard, very old problem of getting NoSQL data in a SQL format.
Yes.
Uh, Kind of trying to structureize the unstructured data. And you already talked about the problem, like we used to get like int, float, and then maybe a JSON in the same
Yeah.
column and so on. So was kind of curious to understand, like, how are you actually able to solve this? Like, how often you get this in Athena? Like, do you go change that SQL code anytime you see one more
Yeah.
conflicting JSON coming in? How do you actually manage it? Or do you actually
Yeah.
flatten this data?
Yes. So if I talk about, like, when we work with the streams, so the stream are basically in the JSON formats, and so we kind of flatten those. We don't go into the like nested JSONs. We just flatten the main JSON data. And if we talk about
Maybe till
the
like first level.
yeah, that's the
Like,
first level flattening.
yeah.
Because it's like if we increase, like if we flatten the nested JSON as well, it will be going to increase our data size and all processing timings. But if but it should, like, it's currently based on our business requirement. Like whenever there is a requirement, we should go for that one. Like as we have already working with the first level of flatten up JSON.
Hmm.
And as the JSON is coming, so sometimes it's like schema is different from the last one. So what we have done, like we have introduced is a wrapper in our ingestion layer that is currently in Lambda. So it's all it's most of the time checks for the standardization, like some like whenever there is a user ID, it should be a UUID. It's not be a like normal random stuff we people can pass.
Hmm.
And apart from that, some more checks are there. And if
What
I
if
talk
some
about,
check is failed? Like, is that what if some check is failed? Is there like a
so
dead
what
letter queue
happens
or
there, like
something like
that,
that?
yeah. So whenever that data gets failed, like we got an alert on ETL group chats, and that data is sent instead of the processing, we send that data to a dead letter queue, so we can manually or look around that issue later.
Hmm. 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 Yeah, like one of the folks, Rajesh, just asked where like he actually used like DynamoDB stream to load the data in like Firehose, which AWS provided, and then from there he basically using Lambda he flattened it and then loaded into Snowflake. So uh, kind of actually curious to understand like is there something which is very unique where Iceberg helps in all of this, other than the, of course, the cost saving and open lake format type of scenarios. In this operation, is there something specific where Iceberg helps, or is it just the actual
Like
like ease of it?
it's not that much of specificness, like as a like if we talk about like our schemas of the tables, it's not that much of complex. So mostly we are using some JSONs and normal integers timestamps. So that's not like Rajesh, we haven't got like we haven't seen any that specific use case of us Iceberg. We just to
Hmm.
go for like as we are currently like developing our product, so we mostly like we have a priority over cost and analysis. So what that's why we are working on the Athena. Like in maybe in future we can go for the Snowflake or the Redshifts, because those are compute based, but we currently don't want to uh, don't want to integrate that much of, like we don't have that much of analysis, like real time analysis and all those things. So
Hmm.
that's why we are focusing on just keeping our costs less by using Athena, and like based on the like scan based cost instead of compute based cost.
Hmm. And kind of like a follow-up question to that, like other than Athena, do you use any other, let's say, query engine on top of these Iceberg tables, or you like query these Iceberg tables only through Athena, or maybe you have like some Spark jobs also running, maybe you're using DuckDB, like everybody is talking about it, so or maybe you're using some DuckDB out there on these Iceberg tables.
So for the like production loads for production analysis, we are currently using just the Athena. And if we're
Hmm.
talking about the POCs, we are doing with the in-house. We are planning to do in-house Trino and Presto,
Hmm.
and we have also tried DuckDB as well.
Oh, would love to like know about it and like some offline conversation some other day. But
Yes,
how those tests are going, like, and I'm happy to do here like all of these tests you're able to do just because of the open lake format of Iceberg.
yes.
Uh, Amazing, amazing. So couple of just going about like other questions that other folks have asked. One more kind of interesting question from Akshay. I think we didn't touch that point till now, which was like, what is the partition strategy that you have particularly used for these tables, and
Mhm.
how were you able to define it? and use Athena to do this?
So if you're talking about the partitioning, so like like our company start and set up in around mid of the 2017. So we have the data from like last 5 to 6 years of data. So if we talk about like before, let's Spark in after the like in the Spark, we don't have that much of the partitionings and the power. Like it takes some time to introduce some partitioning over that. So when we came to Iceberg, we easily like we introduces some Iceberg basically uses the hidden partitioning. So there is no need to provide that partitioning that information to the catalog that we are currently using. So it's under the hood, it automatically handles that. It handles that. So when we talk about partitioning, we just introduce a new column. Like just like I want to partition the data based on a year. So on the created date from a column called created date, we just get taken out the uh, year of that specific data, and we use that for partitioning.
Hmm.
Even that even that same partitioning is also getting used when we are working with the compactions, like when we are rewriting the data, because we know the data that is written today is basically the latest one, so it's going to be under the latest month of current month of that one. So
Hmm.
that things we used for reducing our scanning of the data as well as in Athena, like
Hmm. So majorly like a time updated ad or created ad
yeah,
based.
these things we have used.
Uh, hmm.
And based on some like business requirements, sometimes like some scorings and all those things, we have also introduces partitioning there. Yeah.
Interesting. And how do you actually change this partitioning values? Like if you go and change, let's say for now, imagine let's say you were just using maybe let's say
We just
updated ad.
talk about it's just think it as a like a Postgres database or some database. So you just go there. You want a new column to on which you want to introduce a partitioning. So it's the alter table, add new column, and then provide the column definitions like this data, and this column has the data from like another created date and some string and all those things, some methods. Then after that
Hmm.
we have to again alter your update your table while saying like alter table partitioning again, then just add the new column you have introduced, so it will rewrite the data again.
Oh, interesting,
Yeah.
interesting. And having these hidden partitions, like what is the or maybe user-defined partition, like what is the comparison between these two things? Where exactly do we find better query performance? Were we able to do some benchmarking over there?
So if we talk about the like hidden partitioning, so
Hmm.
uh, like we are currently using a catalog that is like AWS Glue catalog. So we have to register the partitioning there
Hmm.
when we want to read the data using in Athena, but like it's still the same. It's a hidden, or even we can say the normal partitioning.
Hmm.
Like hidden partitioning just provide much more flexibility over scanning of the data and querying of the data, like by the performance. Because
Hmm.
glue can Athena what Athena does, that like Athena creates its own metadata when reading like when storing that data. But so let's assuming we have 4 files we have currently. Okay,
Hmm.
on top of that you have just a one file which consists all the data of all the five files that are sitting in a S3 bucket. So now you have just a single point to interact with. You go to a single file, you ask them like which data is there, like which partition is there. But when we go into like AWS Glue catalog, like normal partitioning, you have to
Hmm.
open, like you have to go on all the 5 points, like all the 5 files metadata, and then you got uh, so it's gonna take time. It's just simply
Hmm.
so there we reduces our like we get the efficiency of performance and all those
Makes
things.
sense.
Yeah.
Makes sense. And like kind of like taking a little bit tangential, like given we have been talking a lot about Iceberg, a small tangential would kind was kind of curious. Like we talked about like DynamoDB to Iceberg type of pipeline as well. What type of strategy did you end up taking, and like what was the pros and cons? Like, were we doing a lot of incremental things, or maybe is it like a full refresh, or maybe a CDC based log based approach? What type of frequency are we talking about here, and so on?
So, like as a data dynamo, if you go for the DynamoDB, we started like first concern was to like do initial extraction, like the full extraction of a DynamoDB, and DynamoDB doesn't provide that much of functionality over its data. So
Hmm.
either you have to scan the data, scan the whole DynamoDB, or you have to extract the data into S3 bucket, then running another Spark jobs and all those things.
Hmm.
And apart from that, like there is only one way to capture those changes in and that are DynamoDB streams.
Hmm.
And even though when we about like after getting those item level changes, we've faced another issue with before we started to uh, introduce our own ingestion layer instead of a DynamoDB, or like instead of a Lambda. But what happens there? Like another thing is there, like that DynamoDB only that DynamoDB streams work freely with Lambda. But if you introduce your own ingestion layer, then they're gonna cost you. So this is basically like AWS is getting going like playing with us.
Makes sense. Makes sense. Yeah, AWS, we are using their compute, we are using their catalog,
Yeah.
so why not everything else as well? Makes sense. Makes sense. I guess these were the questions I particularly had. If anybody has any more questions, we'd love to like talk about them. Akshay has one more. Like we mentioned like time travel and Iceberg creating snapshots for each transaction. uh, he's giving an example where he's talking about like let's assume there are 10 snapshots there. Can we roll back to any snapshot version in terms of data corruptness, or are there any like restrictions?
Rohan, I didn't get you. Can you just repeat it? Like, sorry. Yeah.
Sure. So imagine, let's say, in time travel, we are creating those snapshots, right? So imagine, let's say,
Yes.
we create, let's say, 10 snapshots for a single table. Are there any restrictions for us to go to a certain, let's say, only the last snapshot or something, or I can go back to any of these versions or roll
No, no.
back to any of these versions?
Yes, it's totally handled by you. Like you have to provide like how many last snapshot you want to Iceberg to handle. Like and if you want to handle like last 10 changes of a data, so you can just handle those things as well.
Oh, interesting,
Yes.
interesting.
So
And
even though
how
like
long of a history that you normally keep in this?
so it's
Like it's like I'm
7 days
keeping the history,
currently.
right?
Currently, I think it's 7 days.
Hmm,
Yes.
interesting, interesting, interesting. Awesome.
Like
Awesome. Awesome.
so there are two features like either you introduce like a timestamp like at how many time like and like till how many days it's gonna be there, or either instead of time you can just tell him like last seven snapshot will be there.
Hmm.
Mhm.
Makes sense. Makes sense.
Yes.
Awesome. 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 Yeah. So, majorly these are the questions. Like, uh, we are also running out of time actually. Uh, but thank you so much, Varun. If you have Uh, any more questions? Any more thoughts? I think there's already a conversation going on in our
Yeah.
chats. Like, hey, Treat, hey, Joel. Would love to make an interaction between you guys. Would love to actually be part of these questions as well. Kind of looks an interesting conversation, especially uh, with respect to like how to manage that file system and so on.
Yes. Yes.
So I'd love to like do this, keep doing this for a longer period of time. But yeah, like all good things come to an end. So thank you, Varun, for sharing these amazing, valuable insights, walking through the journey, and thank you so much, everybody who was here.
Yes,
I
sure.
really hope this was useful. This was very useful for me, particularly. Got to learn a lot of these things, lot of these small caveats around Iceberg, caveats around how to manage it, how not to, what not to do as well. So
Yes.
thank you so much, Varun, for doing this.
Thank you so much. And
Thank you, thank
we,
you. Keep
sure.
keep listening to us, and yeah, like I think we'll be back soon again. Thank you so much, Arun. Yeah,
Thank you so
bye
much,
bye,
man.
everybody.
Bye, guys. By the way, guys can like ping me on LinkedIn. So like there are a lot of questions still pending. We can connect around
Yep,
and discuss.
yep. Let's do that. We have we can share our LinkedIn. We can share
Yeah,
our
yeah. Sure, sure.
uh, mail IDs as well. Like we can continue the discussion over there. Thanks.